Hi, this is Steve Gibbs. I'm a lecturer with the University of Texas at Arlington, working in the Department of Electrical Engineering, mostly in the area of microcontrollers and radio devices. Today it's going to be my privilege to share with you systems of linear equations. Let's move on. To this point, we've already looked at how to solve a linear equation in several different ways. We've looked at how to do it with substitution, how to use the graphing process to see what the equations work out to. We spent some time looking at matrix algebra. Then we looked at Cramer's rule. So we've got the fundamentals down. Now let's move on to some engineering examples. This topic is going to focus specifically on mechanical engineering. We'll save electrical engineering for the following lecture. In the mechanical engineering world, let's assume we have a 50 Newton weight hanging from a surface. Two cables are suspending this weight. One of them is measured to be at an angle of 30 degrees down from the horizontal, and the other is measured at 45 degrees down from the horizontal. As we look at the forces, we can see that the tension is this way while the weight is pulling inward. For the other one, the tension is pulling out against the weight, which is pulling in. So this will set our sign conventions as we move forward. But before we do that, let's look at the trigonometry involved and just do a quick review. When we have a triangle, we define that we have three sides with an angle, and with that angle we have the adjacent side, the opposite side, and a hypotenuse. Trigonometry tells us that the sine of this angle is equal to the opposite divided by the hypotenuse. Similarly, the cosine is the adjacent divided by the hypotenuse. And then the tangent is the opposite divided by the adjacent. The next question is, how is that going to assist us as we solve this problem? Let's go back to the problem we've got. We have an angle that's defined for us, either 45 degrees or 30 degrees. The weight is pulling straight down, which is opposite to the angle. We also have a horizontal component pulling in, and that is the adjacent to the angle. So if the opposite is involved with our hypotenuse, that means that we're going to be using the sine function to find and that'll give us the vertical force. The horizontal force is going to be defined by the cosine function. So let's put this into an equation. In the vertical direction, we've got our tension 1, and we have the sine of 30 degrees in order to obtain the vertical component. And then we have tension 2 times the sine of 45 degrees in order to get the vertical component of that. And we know that together the weight of our object is 50 newtons. In the horizontal direction, since the tension is pulling outward, the force is pulling inward, and that's at the negative sign, and that's the cosine of 30 degrees for the adjacent angle. And then the second tension, tension 2, and the cosine of 45 degrees pulling in. So now we have our 2, and in In this case, this tension 2 is a positive in order to get the directions right. Let's change color a moment. If this is pulling to the right, we're calling that negative. Since this is pulling to the left, we'll call that positive. That way the signs will agree for us. The first technique we're going to use is substitution. So we set up our equations, and now we're going to solve by putting in the values. Now we can save and keep it symbolic, sine of 30 degrees, cosine of 45 degrees. We could hold that for a number of steps in the equation, or we can put the numbers in right away. For this particular problem, I've chosen to put the numbers in immediately. Solving the first equation, we isolate 50 minus 0.707 T2, and then we divide through by 0.5, and here's the equation we come up with. So now we have isolated T1 in terms of T2. Clearing the denominator, and we have 100 minus 1.414 T2 is equal to T1. The second step in the process is to substitute that value, 100 minus 1.414 T2, into the second equation. As we do this, we work out the numbers, and now we can isolate T2. So the T2 is going to be equal to 86.6 divided by 1.225 plus 0.707. That allows us to know the actual value of T2, which works out to 44.83, and that'll be in newtons. Now we'll take the value we've learned for T2. So here's the value we just solved for T2. We'll substitute that back into the first equation, 0.5 T1 plus 0.707 T2 equals 50. And now all we need to do is find T1. Everything else has been worked out for us. And we learn from that that T1 is 36.6 newtons. Okay, putting the pieces together, we see that for the 50 Newton weight, the tension on the first cable, the one at 30 degrees, was 36.6 newtons. The tension on the cable at 45 degrees was 44.8 newtons. Then together they suspend our weight. Now we solve this using substitution. We're going to end this lecture here, come on back for the next lecture, and we'll solve it using matrix algebra, and then look at it using Cramer's rule.